Okay guys, we're going to finish chapter 3 today, which was on electrons. And in this video we're going to talk about a couple of things that are very important. So before we start, I'd like you to make sure that you have a couple things out. Number one, your guided notes. Be filling out your guided notes as we go through this video. And also have out and available is your periodic table. We're going to talk a little bit about we're going to fill some more things out on that periodic table. So, okay, let's get started. We're going to talk today about valence electrons. Valence electrons are very important, and like I said, we're going to be talking about them for the rest of the year. So, you have to write down the definition for valence electrons. So here it is. Valence electrons are defined as the electrons in the atom's outermost orbitals. So they're the very farthest away from the nucleus, and they're those associated with the atom's highest principal energy level. So this is what I kind of like to define as valence electrons. They're the electrons in the highest energy level. So we just find the highest energy level, count up all those electrons, and that's how you determine the number of valence electrons. Okay, for example, if you look at bromine, and we write its electron configuration. Well, this is its electron configuration. We start with 4s2, 3d10, 4p5. Now, going back to this definition, the valence electrons are in the highest energy level. If you look here, the highest energy level, remember with electron configurations, this number out front tells us the energy level. So the highest number there is a 4, and we see it in two spots. We see it here and there. Now, how you determine the number of valence electrons is you simply add up the electrons that are in the highest energy level. Well, this exponent here tells you the number of electrons. And so we've got 2 electrons in the 4s orbital, and there's 5 electrons in the 4p orbitals. And so if you add them up, 2 plus 5 is equal to 7 and so bromine would have 7 valence electrons. Now you might be saying, well, what about these 10 electrons? Well, if you look here, that's in the 3rd energy level. Their valence electrons are in the highest energy level. So make sure you find the highest number there and just add up those. Okay? And so these electrons don't count. They're in a lower energy level. Okay, so that's what valence electrons are. A lot of teachers will say they're the outer shell because they're the farthest ones away from the nucleus. But anyway, they're just the electrons that are in the highest energy level. Okay, we're going to learn how to determine how many valence electrons each atom has. We're going to do all of the atoms on the periodic table. And so have your periodic table out and ready, and we'll show you how to do that. Okay, by looking at the periodic table, it's easy to determine the number of valence electrons that the atom has. For those elements that are in group 1, now groups on the periodic table go in vertical columns. That's a group. So if we look at the first column on the far left side of the periodic table, it starts with hydrogen, and it goes down to francium, Fr. All of those guys have 1 valence electron. Group 2, which is the next group to the right, has 2 valence electrons. That's the group with beryllium in it. Group 13, now we skipped up 3 through 12. We're going to group 13 now. Group 13 has 3 valence electrons. Group 14 has 4, and it just keeps going all the way over to the very far right column on the periodic table, which is known as the noble gases. Well, group 18 is the noble gases, and they have 8 valence electrons. So I'd like you to get your periodic table out. We're going to label the periodic table so that it's easy for you to find how many valence electrons an atom has. Okay, so your periodic table looks like this. I want you to write a few things. So in this first group, so it goes all the way down, so hydrogen all the way down to francium, all of these guys have 1 valence electron. So I'd like you to write 1 VE. The VE stands for valence electrons. Okay? Group 2, which is this group here, they have 2 valence electrons. So all of these elements here have 2 valence electrons. Now we're skipping groups 3 through 12, and we're coming over here to group 13, the borons group, and they have 3 valence electrons. And it just keeps going all the way over, so this is 4 valence electrons, 5 VE, 6, 7, you move this over, and it finishes with the noble gases, which have 8 valence electrons. Now there's one exception. There always has to be an exception, right? There's one exception on the periodic table, and that's, you might have already guessed, is helium. Why is helium an exception? Well, we wrote here that the noble gases have 8 valence electrons, but how many electrons does helium have? Well, it only has 2 electrons. So I want you to put in this box somewhere 2 VE. So helium has 2 valence electrons. Everyone else that's a noble gas, so neon, argon, krypton, and so forth, all of these guys have 8, but helium only has 2, so it has 2 valence electrons. So just be aware of that. Even though we put 8 right here, we've just got to know that helium only has 2. Okay? And then we skipped over a big block of elements right here. Groups 3 through 12. And then we also are not going to say anything about this block of elements down here. These are the, so this chunk of elements right here, they're called the transition metals. And these guys are called the inner transition metals. Their valence electrons are a little more difficult to determine. We're going to talk about metals in the coming chapters, but for right now, we're just going to leave them aside and not talk about the valence electrons that they have. But I just wanted to bring this up as well. When we were doing electron configurations, this was the 4th energy level. Okay, but then what happened as we moved to this block of elements? Well, it dropped down an energy level. And then we came back up. This would have been back up to 4 when we get over to the P. This d orbital drops down, and so does this f orbital. And so they're not considered valence electrons anyway. They would all have 2. If you looked at the electron configurations, they would all have 2 valence electrons. But I'm never going to ask you questions about how many valence electrons the metals have. So we'll just leave that for now. Okay? So let me see if we've got this. I'm just going to do if you're watching the video, I'm just going to ask you some questions to make sure that we understand how to find valence electrons. So if I asked you how many valence electrons would nitrogen have, what would you say? And hopefully you're saying 5 valence electrons, because every element in this whole group here has 5 valence electrons. Okay, let's try another one. What if I asked you how many valence electrons does calcium have? Okay, calcium's right here. Hopefully you're saying it has 2 valence electrons, because every element in this group has 2 valence electrons. Okay, let's try a couple more. How many valence electrons does let's go krypton. How many does krypton have? And hopefully you're saying 8. Remember, the only one in this group that doesn't have 8 is helium. It has 2. How many valence electrons does aluminum have? And hopefully you're thinking to yourself it has 3 valence electrons. Okay? One more. Let's do cesium. How many valence electrons does cesium have? Well, it's in this group here. It has 1 valence electron. So when you look how easy it is to determine the number of valence electrons that an element has. Okay? And hopefully that makes sense. But I want to make sure that you have this on your periodic table. You've labeled all these groups and how many valence electrons they have. Okay? And that will be easy. Okay, we're going to finish up the chapter by talking about electron dot structures. Move this back over. Okay, electron dot structures. you're supposed to write something in your guided notes here, so let me put that up. Electron dot structure consists of the element symbol, representing the nucleus, surrounded by dots representing the element's valence electrons. Okay, so you're supposed to write, I think, electron dot structure. So let me just go over what an electron dot structure is. We use the symbol of the element, and that represents the nucleus and all the inside electrons, all the inner electrons. And we use dots, which we'll show you here in a second, to represent the number of valence electrons that the element has. So let's do an example here. I've got, and it says, the example says carbon's electron dot structure. So if we look at carbon on the periodic table, it's in group number 14. And if you look above that group, you should have the number of valence electrons written down. And hopefully, you have 4 valence electrons written above there, because carbon has 4. Now with the dot structure, the symbol represents the nucleus and all these inside electrons. So carbon's symbol is C. So we just draw C. That represents the nucleus of the carbon atom and all those inside electrons. And then we're going to use dots to represent the valence electrons. Well, carbon has 4. So we're going to start, here's how you do the dots. You always start at the top, and you just work yourself around, putting 1 dot on each side in a clockwise manner. So 1 at the top, then 2 on the right, and 3, and 4. And so 1 dot per side. Okay? And so it's got 4 valence electrons. And there's carbon's electron dot structure. This would be the answer. Let's see if you got this. I'm going to do a couple more examples just off the top of my head. Let's see if we can do nitrogen's electron dot structure. Okay? So first thing, we're going to look up nitrogen on the periodic table. How many valence electrons does it have? Okay, it's in group 15, and they all have 5 valence electrons. Okay? So now let's draw its dot structure. We start with the symbol. Nitrogen symbol is what? And hopefully you're thinking that it's N, because that's what it is. We've got to draw the valence electrons now. The dots represent the valence electrons. We always start at the top, so there's 1, 2, 3, 4, and now we're full. We go back to the top and make another one. So each side can hold a maximum of 2 electrons. And so one side is full, the other 3 sides have 1. So there's nitrogen's electron dot structure. Let's do one more. Let's do a noble gas. Let's do neon. Okay? Let's do neon's electron dot structure. So if you're watching the video, hit pause right now and see if you can do this one before you see the answer. Try it on your own. Okay? So neon, if you look at the periodic table, it's a noble gas, and they have 8 valence electrons, except for helium, which has only 2. So neon has 8 valence electrons. Now we need to know its symbol. So if you look up its symbol, it's Ne. Okay? And we've got to put 8 dots around it. So we're going to start here. 1, 2, 3, 4, 5, 6, 7, and 8. Okay? And so that would be the electron dot structure for neon. Notice there's 2 dots on each side. That's the maximum number of dots you can put on one side for an electron dot structure. Okay, very simple. I've got a practice problem here. Practice problem number 27. And it says, for each of the following atoms, determine the number of valence electrons and write the electron dot structure. So I've got 4 of them. Please hit pause right now. You guys work these problems, A through D. Remember, I want the number of valence electrons and its dot structure. So hit pause. When you got it done, hit play and see if you did them correctly. Okay, let's see if you got these right. So oxygen, if you look at the periodic table, oxygen has 6 valence electrons. So I'm going to put 6 VE right here. We write its symbol, which is O, and now we need 6 dots. 1, 2, 3, 4, 5, and 6. And so that's the electron dot structure for oxygen. Okay, let's go to B. Boron. Boron is in group 13. Those guys have 3 valence electrons. Boron symbol is B, and so we need 3 dots. 1, 2, and 3. And that's boron's electron dot structure. Iodine is in group 17. All of those guys have 7 valence electrons. So we're going to write its symbol, which is I, and we're going to put 7 dots around it. 1, 2, 3, 4, 5, 6, and 7 dots. Okay? And there's iodine's electron dot structure. For potassium, I'm going to move it up here just for some more space. Okay? Potassium is in group number 1, and it has 1 valence electron. Its symbol is K. And so we just put 1 dot, starting right there. And so that would be potassium's electron dot structure. All right, very simple. I mean, that's it. Just look up the number of valence electrons it has. The dots represent the valence electron. Before I move on, the symbol, the K here, would represent potassium's nucleus and all the inner electrons. Remember, potassium, if you look at its atomic number, is 19. So it's got 19 electrons. Only one of those 19 electrons is a valence electron. So this would represent the 18 inner electrons. Now the dot represents the valence electrons. Okay. And so with the 18 inner and the 1 valence electron that it has, that's the 19 electrons that potassium would have. Anyway, that's hopefully we understand the electron dot structures. I think they're pretty easy, but they're almost essential to figure out because we're going to be using them going forward in the course. So, okay, finally, we'd like to finish by talking about this rule that's very important in chemistry. It's called the Octet Rule. Now, I want you to think to yourself, what does oct mean? Now, I want you to write this note in your guided notes. What does oct mean? Well, it means 8. Okay, like an octagon has 8 sides. And so when you think about the octet rule, we're thinking about 8. And so let me show you what the octet rule is. Here's the definition. The octet rule states that atoms tend to gain, lose, or share electrons in order to acquire a full set of valence electrons. And a full set of valence electrons is 8. And so if you look at the periodic table, who on the periodic table has 8 valence electrons? And that's the noble gases. So the noble gases are very stable elements. In fact, they won't do any of this stuff. They're not going to gain any electrons from anyone else. They're not going to give anyone or lose any electrons. They're not going to share electrons with anyone else. They are happy. They are very stable as is. And so that's kind of why they're called the noble gases. They're like the nobility. They're like the kings. They're not going to mix with everyone else on the periodic table because they want those electrons. They already have 8. But everyone else on the periodic table wants to either gain more electrons from somebody else, they're going to give their electrons to somebody else, or they're going to share them with somebody else so that they can come up with this 8 valence electrons and obey the octet rule. Okay? And so let's go through an example of this. If we look at sodium, sodium's atomic number is 11, and so it's in group 1. It has 1 valence electron. And it will like to lose that 1 valence electron because then it will be just like, it will have the electron configuration of neon, which is a noble gas. So it really wants to get rid of that 1 electron. If we look at its electron dot structure for sodium, it looks like this. Sodium has 1 valence electron, so 1 dot there. Okay. Well, let's look at chlorine on the periodic table. Chlorine has 7 valence electrons. And it's really close to 8. And so it would really like to gain 1 electron from somebody. We'll take it from anyone, really. And so if if we take that and put chlorine here, it says, let's draw chlorine's electron dot structure. 7 dots. 1, 2, 3, 4, 5, 6, and 7. And so hopefully you can see now, after we draw those dot structures, why sodium really likes chlorine and chlorine really likes sodium. Okay, because together, if these guys were to get together, they could share electrons, and that's what they do, and they make sodium chloride. So they form a bond here. They come together, and when they come together, each atom here, both sodium and chlorine, feel like they have those 8 valence electrons, and so they'll form a compound. And hopefully we can see why. This is going to be the beginning of chemistry now. We're going to talk about all the elements on the periodic table and who they can form a bond with so that they obey this octet rule. And when they form a bond, they become a compound or a molecule. And so that's what we're going to talk about the rest of the year. We're going to make new molecules or new compounds. And they do that by making sure that they find somebody else on the periodic table that when they come together, they can have that 8 valence electrons like sodium and chlorine here. Anyway, hopefully that kind of makes sense. It's kind of a preview of what's coming in the course. So like it says, sodium and chlorine will share electrons in order to gain a full set of valence electrons, which is 8. And they obey the octet rule. All right. I'm going to finish with this slide here. I wanted to show you this slide, and it's kind of a good summary of what we talked about in this video. Let's talk about a couple of these. Maybe oxygen. If I talk about oxygen and we look at its electron configuration here, let me ask you, what's the highest energy level in oxygen's electron configuration? Well, we have a 2 and a 2. So 2 is the highest energy level. If we add up those electrons in that energy level, we get 2 and 4. What's 2 plus 4? Well, that's 6 valence electrons. And so that's why you see 6 dots around oxygen. Okay? Let's do one more. Let's do neon down here. If we look at the electron configuration here, the highest energy level is 2. If we add up all the electrons in there, 2 plus 6 is equal to 8 valence electrons. And that's why when you look at the dots here, there's 8 dots around neon symbol. These 2 electrons there don't count because that's in a lower energy level. Anyway, that's kind of why we practiced our electron configuration first, and then we kind of just build on it to find the valence. We just look at the largest energy level and count them all up. Hopefully that makes sense. Oh, before I finish, I want to look at this one right here. Okay. Beryllium has 2 valence electrons, but they drew it a little bit different than I just taught you to do this. Be, put a dot on the top and a dot on the right. Well, I guess technically the way they drew it here is more correct. Let me ask you this. Do electrons like to be by each other? If we have 2 electrons here, and I was to hold them and I just let them go, what they're going to do is fly apart. They don't like each other. Like charges will repel each other. And so this technically is a better way of representing it. So you can put BE with a dot on the left and right, and that's correct. Could you also write it like this, with the dot on the top and the bottom? Yeah, all of these here, all of these are correct. I mean, if you wrote that on a test, I'm not going to mark it wrong. But just be aware, what they're doing is trying to separate the electrons, because the electrons in reality will move so that they maximize the distance between them. They don't like each other, they repel each other. So this one actually, these 2 are more correct. Anyway, that kind of ends chapter 3, which was on electrons. Hopefully we learned something. Electrons are really cool. They're what produce light. They are found in orbitals. We talked about all the orbitals. We learned how to write electron configurations, orbital diagrams, how to find valence electrons, how to write electron dot structures. And So hopefully we learned something about the electron. Okay guys, before I stop, you now know enough to complete a worksheet in the student workbook. So please turn your workbooks to the worksheet that's titled Valence Electrons and Electron Dot Structures. Again, it's called Valence Electrons and Electron Dot Structures worksheet. So you can complete that, and hopefully it will be pretty easy after watching this video. Anyway, hopefully that helps.